welcome to Flash Forward. I'm Rose, and I'm your host. Flash Forward is a podcast about the future. Every week, we take on a specific possible or not-so-possible future scenario. Every episode starts with a little trip to the future before we come back to now to talk about how that would really go down. Got it? Great. This week, let's start in the year 2021.
Chairman Yerk, Ranking Member Axe, and members of the subcommittee. Thank you for the opportunity to testify before you today and for your ongoing support for the Centers for Disease Control and Prevention's work in global health. CDC works 24/7 to save lives and protect people against health threats. As per our agreement with Congress, the CDC has adopted a computerized modeling system for financial decisions over $1.3 billion. And since this proposed set of initiatives greatly exceeds that number, we will be using the Ganges RED system to determine the best outcome. We have fed the computer data on mosquito-borne disease outbreaks, mosquito ecology, the chemistry of pesticides, and the genetic malleability of the insects. The system also has scraped the web to consider social media, blog, and news content about this issue to weigh the arguments for and against each plan. A full report on the processing time and total data crunched in this decision tree should be showing up on your screens now. You'll find full text report under the tab labeled Decision Number 18. And with that, I'd like to let the system read the outcome.
Hello, you have told me many things about mosquitoes. There are many possible outcomes to each of the decisions I might make, but based on the data I have been provided, and the data that I have gathered, the optimal solution for humans is as follows. Eliminate the following mosquito species: Aedes aegypti, Aedes albopictus, Aedes ficii, Aedes fulvus pallens, Aedes grosbecki, Aedes infirmitus, Aedes japonicus, Aedes melanimon, Aedes nigromaculus, Aedes provocans, Aedes sollicitans, Aedes squamiger, Aedes sticticus, Aedes stimulans, Aedes taeniorhynchus, Aedes triceratus.
Please return to your homes. Designated public safety sprays are beginning in 20 minutes. Anyone outside their homes will be escorted to the nearest precinct. Listen for the all clear sign before leaving your homes. Please return to your homes. Designated public safety sprays are beginning in 20 minutes. Anyone outside their homes will be escorted to the nearest precinct. Listen for the all clear sign before
Okay, so in this future, we decide to eradicate all of the mosquitoes. This is something that people have proposed for a long time, but it's been in the news again recently because of the Zika virus. Now, getting Zika is mostly just kind of annoying. 4 out of 5 people who get it never show any symptoms at all. And those who do show symptoms feel achy and get a fever, but rarely experience anything worse than that. The problem, and the reason that you've probably heard of Zika, is that the Zika virus seems to be connected to a rise in birth defects. So pregnant women who get Zika may, for reasons that nobody really understands yet, give birth to babies with something called microcephaly, which is basically an abnormally small head and brain. Now, it's hard to say just how many cases of Zika there are or how many of the birth defects we're seeing are actually related to Zika, but we do know that Zika is not the only mosquito-borne disease, and it's not even close to the most deadly, not by a long shot. Here are some statistics. According to the World Health Organization, there are 20 million cases of dengue virus every year, and there are 214 million cases of malaria, 438,000 of which are deadly. In the United States, an outbreak of West Nile virus that started in 1999 infected 41,000 people and killed 1,700 of them. Since 2005, there have been 1.9 million cases of chikungunya virus documented in East Asia. And as of last year, 1.3 million cases of the virus have been documented in the United States and Latin America. Yellow fever infects 200,000 people every year and kills about 30,000 of those people. That's a lot of numbers, but all of these diseases are carried by mosquitoes. In fact, some people call mosquitoes the deadliest animal in the world. For comparison, snakes kill about 50,000 people every year. Humans kill about 475,000 other humans every year. And mosquitoes, all told, kill 725,000 people every year. So what would happen if we just got rid of them? Would we miss them? To answer that, the first person I called was Dr. Cameron Webb.
I don't think many other people track mosquito outbreaks as much as perhaps I do. My name's Dr. Cameron Webb. I'm a medical entomologist with the University of Sydney and New South Wales Health Pathology here in Australia.
He's the guy that everybody in Australia goes to with mosquito questions.
You know, if a drunk person passes out on the edge of the wetland, are they going to die from blood loss because of mosquitoes?
People ask you that?
Yeah, that's one of the questions people ask me.
I'm guessing the answer is no.
No, I don't think so.
Okay, I won't worry then.
So I asked him, just how important are mosquitoes? If we get rid of them, what happens? And the short answer is that we don't really know.
There's some real gaps in our knowledge about the ecological importance of mosquitoes and what role they play in the environment. And one of the reasons for that is that it just hasn't been very well studied. And I guess it comes as no surprise that when scientists are drawing up a list of priorities for mosquito research, understanding why they spread disease and understanding how better to kill them are far higher in our list of priorities than working out what might find mosquitoes important to their life. So we just don't know.
What we do know is that a lot of animals eat mosquitoes, birds, bats, other insects, but we don't really know how important that food source is for them.
We had a look at these insectivorous bats, and a student of mine, he collected a whole lot of bat poo from a whole range of these small bats. And what we did is we looked for the presence of mosquito DNA and moth DNA. And what we found was that all of the bats were eating moths, but only about half of the very smallest bats were eating mosquitoes. And what we really concluded from this was that mosquitoes were more of a snack food than a staple in the diet of these bats.
And these mosquitoes that the bats eat, they're usually not the ones that transmit disease to humans. It turns out there are somewhere between 3,000 and 4,000 different species of mosquito, and most of them don't kill us. It's actually just a small handful that carry most of the really bad diseases that we talked about earlier. And the one that is the most dastardly is called the Aedes aegypti.
Aedes aegypti is a fantastic vector of dengue viruses, chikungunya virus, yellow fever virus, and Zika virus as well. And so it's the yellow fever mosquito at the moment that is driving the outbreak of Zika virus in the Americas.
If we're going to try and kill all the mosquitoes in the world, this mosquito should be the first one on the list for a whole bunch of reasons.
This is a mosquito that is found in relatively low abundance. One of the reasons it drives these big outbreaks of disease is not because there's so many of them, but that they have a habit of taking a whole series of small blood meals when they're feeding. So what that means is that instead of a wetland mosquito biting an animal once to get its whole blood meal for each generation of eggs, the yellow fever mosquito might be biting a lot of different people, and so it has the potential to infect a lot more people, if you like, during its lifetime.
The Aedes aegypti is a sneaky mosquito. It has a unique ability to sort of bite you when you're not expecting it. It does things like it goes for the back of the knee and the back of the leg and the back of the neck and so forth. Things that places where you might forget to cover up, or you might forget to spray your repellent. And it also breeds in really tiny places, like literally upturned bottle caps full of water are a perfectly happy home for an Aedes aegypti to produce more of that species.
That's Maren McKenna, a journalist who covers public health and diseases. You might remember her from our episode on antibiotic resistance, and she's back to give you some more nightmares.
There's even a phenomenon called airport malaria. It happens at least once a year in most parts of the United States that a mosquito carrying the malaria parasite flies out of a cargo hold and infects someone in the vicinity of an airport.
McKenna says that we've been fighting against the Aedes aegypti for a really long time.
So in 1793, there was an epidemic of yellow fever in Philadelphia that killed about 10% of the city. At that point, Philadelphia was the capital, and they actually had to relocate the capital because the epidemic was so bad. In 1853, there was an outbreak in New Orleans that was so bad that the city authorities suppressed the news of it. And unfortunately, I have to say, it's a bad mark for our profession that the press cooperated with it because they were afraid that if the news got out, New Orleans being such a major port, at that point, I guess, the major port of the southern United States, that the city would be quarantined and trade would be shut down and the city's lifeblood would be cut off. So thousands of people died. In 1878, there was an epidemic of yellow fever in Memphis that killed a third of the city. There's one historian called it the worst urban disaster in American history. Let's see, in 1885, there was a dengue outbreak in Austin. Austin at the time had 22,000 people. It was a very small town, and 16,000 of them got sick. And there were outbreaks of dengue in Charleston and Savannah and Galveston.
And America responded to all of this in kind of the same way we're responding to it now, trying to figure out how to get rid of mosquitoes.
What ended malaria in the United States was sort of the first big mobilization of public health in the United States, which was the founding of the CDC, which we now know as the Centers for Disease Control and Prevention, which is the public health agency of the U.S. and effectively the disease police for the world. But when that agency started, in the early days of World War II, it was called the Office of Malaria Control in War Areas, which makes a really bad acronym, by the way. No wonder they changed it. And the reason they needed an Office of Malaria Control in war areas was because most of the big places that were pushing along the war mobilization, Fort Benning, the places that made battleships, like the places that put soldiers onto battleships, like Newport News, the places that made Sherman tanks, all the big production of people and materiel were almost all in the South, where malaria was just an endemic disease. And so malaria took out so much of the productivity of the war effort that they actually needed a government office to keep it down. So all that the CDC could do at the time was use things like machine oil to literally go out and spray ditches along the roadside to make sure that that mosquito larvae were killed.
And eventually they turned to a pesticide that you might have heard of called DDT. Now, DDT is very good at killing mosquitoes. In 1958, Brazil was declared completely free of Aedes aegypti by the Pan American Health Organization, and the United States stopped seeing big outbreaks of mosquito-borne diseases for years. That's all thanks to DDT, but we don't use DDT anymore because of its impacts on the environment. So now, mosquitoes carrying their diseases are coming back. The U.S. has cases of dengue again, and we are once again trying to picture a future without mosquitoes. So without using DDT, how do we do that? How do we get rid of mosquitoes? Humans are pretty good at causing the extinction of larger animals. We've managed to kill all of the dodos, the Bali tigers, the moas, the Japanese sea lions, the great auks, the thylacines, the Guam flying foxes, the western black rhinos, etc., etc., etc. But mosquitoes are a lot trickier.
Yeah, I would not like to be in charge of eradicating mosquitoes. It would be a tough job. And one of the reasons is that mosquitoes, particularly these urban mosquitoes like the yellow fever mosquito, they're so secretive. There's places where they're breeding and hiding and out of view that getting to all of them would be extremely difficult.
So how do we do it? Probably using a combination of things: pesticide, land management, education, and more recently, people have been talking about using genetic modification. Not on humans, like we talked about in episode 20 from last season, but on the mosquitoes themselves.
So what this means is we release males because male mosquitoes don't bite you, only females do. So we release the males carrying this self-limiting gene. They go off, they mate with females, and then all of the offspring die. And that's it, really, pure and simple.
That's Hayden Perry. He's the CEO of a company called Oxitec that makes these genetically modified mosquitoes. And the nice thing about this design is that these mosquitoes can't really go awry like other forms of pest control can.
I mean, our mosquitoes will only do one of two things. They'll either find a female, mate with her, and the offspring will die, and they'll die anyway, or they won't find a female, in which case they'll die. So this is an approach that doesn't spread in the environment, doesn't persist, and can be used to control a mosquito population in an area.
In some situations, these mosquitoes work really well at tamping down the population. But there are challenges to this approach, too.
Look, the big problem with a lot of these approaches is they're not a self-sustaining approach to controlling mosquito populations, in that you would continually have to be releasing the modified mosquitoes.
And if we wanted to get rid of all of the mosquitoes in the world, all of them, every single one, could we even do it with genetically modified males?
Not really with our approach, to be honest. I mean, our approach is very localized and targeted. And the reason for that is mosquitoes don't fly very far. So in its lifetime, a male or a female mosquito will only travel 200 yards, 200 meters in its entire lifetime. We'll release our males, and they will only actually have an effect, each one of them, in the 200 meter or yard radius of where we release them, because that's how far they can fly. So you've really got to plan and target what you do. Now you can clearly release them throughout the whole city, so that you've covered a whole city, and you could do that across many cities. But it would be a little bit impractical, I think, to want to do that across whole countries.
Probably this future involves lots of different methods. But some people are wondering whether we're approaching this whole thing from the wrong direction. Why spend so much money and time on mosquitoes and not, say, the viruses that they carry?
I think sometimes we have to change our perspective on things, because we think about mosquitoes causing the disease, but in many respects, they're innocent bystanders in this process, and it's the viruses or the pathogens that are taking advantage of the mosquitoes to spread from host to host. And so I think my gut feeling is that, you know, if we had a finite pool of resources, it might be much easier to develop a vaccine and distribute that to people, rather than come up with a new insecticide and try to spray every single mosquito on the planet.
Perry has an answer to that. He says that simply having mosquitoes around in the first place opens us up to diseases that we don't even know about.
The sad thing is a couple of years ago we had chikungunya coming into the Caribbean area. So there was one case in St. Martin in December 2013. And then within a year, there was over 1 million cases all through the Caribbean and Central America. And that just goes to show what happens if you bring a new virus into an area where you've already got this mosquito sitting there with its unique capability of spreading disease. Zika is the next one in line, and I think now there is a lot more understanding that, you know, this time round something's got to be done, and we really must find a way of controlling this. But Zika equally, you know, I hate to say this, but it won't be the last virus that this mosquito transmits. There will be others.
But getting rid of just one species of mosquito could backfire. What happens if another species realizes that there's this great opening, that it could just bite all of these people because the Aedes aegypti is gone now? And then you just have another mosquito taking its place and transmitting those viruses again.
It doesn't matter how much our technology improves and how developed we become. You know, mosquitoes don't seem to go anywhere, and we continue to get these emergence and re-emergence of these mosquito-borne diseases that we didn't think were that important, or we thought we had them beat.
When I planned this episode, I figured that McKenna would be in favor of getting rid of mosquitoes and Webb would be against it. She's the public health person and he's the mosquito guy. But here's what actually happened.
If you were ruler of the world and you were asked, should we make these mosquitoes extinct at whatever cost, would you say yes or no?
I think I would feel quite comfortable signing off on the eradication of the yellow fever mosquito. because I think that the potential ecological or environmental knock-on effects to that would be relatively low compared to the significant benefit to human health internationally. However, on no way in the world would I sign off on the eradication of some of the more abundant mosquitoes associated with wetland and bushland areas, because I have little doubt that they're playing a potentially significant role in the life cycles of some of our insectivorous wildlife. So, one species, I'm happy to kind of maybe get rid of that. But for the thousands of others, I'm happy to live on a planet with them.
I would use the scientific dodge of more data needed. It's so much more, would be so much more dramatic to say, oh yeah, just kill all those little buzzers. But, as somebody who writes about public health and epidemics and disasters, I live my life in the realm of unintended consequences. And so as a result, when it comes to big actions, I am very conservative, because I can look back at the history that I write about and see that big actions have often ended us up in places where we really didn't intend to be.
I asked Perry a slightly different question. I know he's all for getting rid of Aedes aegypti, but what if he had to pick between getting rid of all of the mosquitoes or getting rid of none of them?
Whoa. I think I would get rid of mosquitoes if I had a choice.
Yeah.
I don't like them.
As with most futures that we travel to, we don't really know enough to know how this might go down. We could spend billions of dollars trying to get rid of Aedes aegypti only to watch another mosquito species take its place. Or we could watch a collapse in bat species who were secretly eating these mosquitoes that we eliminated. Or we could save millions of lives. Or all three of those things could happen at the same time. The future will be complicated. So what do you think? If you have strong feelings about this future, if you're vehemently anti-mosquito or 100% for keeping the little buzzers around, tell us why. This is a new experiment I'm trying, but I want to hear from you. You can call us at 347-927-1425 and leave a message with your opinion, or you can email us a voice memo at info@flashforwardpod.com. If you want instructions for how to email us a voice memo, go to flashforwardpod.com and there will be a little link for instructions on the homepage. Tell me, should we plan the ultimate swatting, or should we just leave them alone? Flash Forward is produced by me, Rose Eveleth, and is part of the Boing Boing podcast family. The intro music is by Asura, and the outro music is by Broke for Free. The voices of this future are Molly Sauter and Robert Brenner. The episode art is by Matt Lubchansky. If you want to suggest a future we should take on, send us a note on Twitter, Facebook, or by email at info@flashforwardpod.com. I love hearing your ideas. Keep sending them. And if you think you've spotted one of the little references that I've hidden in this episode, email us there too. If you're right, I'll send you something cool. Only one person has gotten this so far, so keep trying. I know you can find them. And if you want to support the show, there are a few ways you can do that too. We have a Patreon page where you can donate, but if that's not in the cards for you, you can head to iTunes and leave us a nice review, or just tell your friends about us. Those things really do help. That's all for this future. Come back next week and we'll travel to a new one.